Pipe jacking and microtunneling are becoming increasingly important for the installation of new service pipes and sewer pipes. The advantages of the pipe jacking and microtunneling process are evident, especially in urban city areas. Pipe jacking causes minimum disturbance along the construction route, so there's virtually no disruption to the flow of traffic or any impact to the local economy. The following animation shows the installation of new sewer pipes DN600 in an urban crossroad with dense traffic. The whole construction site can be located in a way that only one lane is blocked. In our example, 150 meters of sewer pipe are to be jacked from the launch shaft to the reception shaft. At the first stage, the area around the starting shaft is cordoned off to divert the traffic. Due to the compact design of the machine and the small diameter of the starting shaft, there will only be minor disruption to the traffic flow. In this case, the starting shaft consists of a round shaft of reinforced concrete with an inner diameter of 3.2 meters. The compact jacking frame is then placed into the starting shaft, and the slurry discharge pump is mounted on a platform adjacent to the jacking frame. The operating container with the control panel and the hydraulic power pack is located on the top rear side of the shaft. A pipe stalk is then established and maintained in front of the shaft to feed the shaft crane. The slurry feed pump and the slurry discharge pump are connected between the shaft and the control container, and then connected through the separation plant to form a closed slurry circuit. The AVN600 machine consists of several segments. A sleeve shaft with 3 bolt holes connects the cutting wheel with the drive unit. Fresh water is then pumped from the slurry tank and centrally pushed through the machine to pick up the excavated material. The mixed slurry is then picked up by the discharge pump and transported to the separation plant on the surface. The conical crusher situated in front has reinforced cutting bars and is provided with nozzles to inject the fresh water. The drive shaft, which is connected to the cutting wheel, is driven by hydraulic motors. The sleeve shaft lies in a tapered roller bearing. 3 hydraulic motors transmit the rotation via the gear rim to the sleeve shaft and the cutting wheel. The 3 steering cylinders enable the operator to correct the direction of the tunnel boring machine, as well as control the alignment of the machine in curved drives. Therefore, the position of the cutter head is continuously updated with the help of the laser guidance system. To ensure AVN600 has a smooth method of excavation, the machine has 2 integrated water circuits. The standard water circuit supplies fresh water to the annulus via 5 hoses fixed to the inner side of the bulkhead. Several boreholes branch off from the annulus, which supply the chamber situated behind the conical crusher. The fresh water is continuously pumped through the conical crusher chamber and sucked off through the boreholes of the sleeve shaft and transported back to the surface with the shaft slurry pump up to the separation plant. A second hose supplies the high-pressure nozzles used in the conical crusher. These nozzles avoid clogging and agglutination of the crusher chamber in case of cohesive soils. They cut the clay in the crusher chamber with 250 bar water pressure and break up the material. There are also 2 nozzles that are directed to the front part of the cutting wheel. The water coming from the nozzles is mixed with the water of the slurry circuit, and the excavated material is transported to the surface. The cutting wheel excavates the material at the tunnel face, which is pressed into the crusher chamber and is grinded into the appropriate grain size by the spokes of the cutting wheel, which operates in the same principle as a coffee grinder. Large stones are crushed by the discs of the cutting wheel. Sometimes fragments are being driven out to the surrounding soil. Stones falling through the openings of the cutting wheel into the crusher chamber are crushed by the reinforced conical crusher and the spokes of the cutting wheel, and afterwards transported together with the slurry water to the surface. The material is picked up in the slurry circuit and transported to the separation plant through the central slurry discharge hose. The slurry discharge hoses and the slurry feed hoses pass through the center of the jacking pipes via the jacking frame up to the surface. The slurry discharge pump removes the excavated material and pumps it up to the separation plant. The separation plant consists of 2 chambers. At first, the excavated material is pumped into the back chamber, where it settles due to gravity. The overrunning water is filtered and centers in the front chamber, from where the clean water is sucked by the slurry feed pump and returned to the slurry circuit, thus creating a closed system. The product pipes are lowered into the shaft one after the other and connected with snap connectors. The jacking frame works in 3 stages. After approximately 1/3 of the maximum piston stroke, the jacking arms return and the main thrust ring of the jack can advance further. After jacking the product pipe, the connecting hoses, which connect the TBM to the container, are disconnected. The jacking frame is returned to its original position, and the next product pipe is connected. This procedure is duplicated again and again until the whole drive length is completed, reaching the reception pit. Crossing pipes in buildings are no problem with this technique, as they can be easily overpassed or undercrossed. Thus, the machine arrives in the reception shaft exactly at the planned coordinates. The drive is continuously monitored by a laser measuring system. This laser system is positioned in the starting shaft, meeting the target which is installed in the cutter head. The laser determines the reference axis. The laser target identifies any deviation which may occur. The coordinates are transferred to the steering computer in the container and visualized on the screen. Any deviations in position can be corrected by adjusting the steering cylinders at the push of a button on the control panel. The length of the tunnel is recorded by a metering wheel. This information is transferred to the control panel, allowing the operator to visualize the location and direction of the machine cutter head at any time. In our example, the total of 150 meters of new pipes could be realized with only a minimum of disturbance in a difficult infrastructure. The conventional open laying of pipes would have caused major disturbance and annoyance for traffic and the residents.